In our next couple of lessons, we're going to get back into chemical reactions, particularly ones with single or double displacement reactions, and we're going to do some stoichiometry calculations with those in the next lesson, which is all about solution stoichiometry. So if you need to do a quick review of what your single or double displacement reactions are, I would recommend doing that. For the lesson today, you'll want your periodic table handy, you'll want your solubility charts handy, and for your homework, activity series is always a good one to have on hand, and you can use all of those things for any quizzes or evaluations that you would see, but those are some things that you need to be pretty comfortable with. Writing out single and double displacement reactions, writing the chemical formulas for their reactants and products, being able to balance the equation, being able to write in the proper states, and then we take all of that knowledge and apply it to some problems. So what we're going to learn today first are how to write out some equations involving ions. They're called total and net ionic equations. The idea of writing them is fairly straightforward. So today's lesson, we're just going to learn how to write out the equations. And in the next lesson, you'll see some of these equations come back in a few different ways when we start doing some calculating problems. So let's take a look at an example so you can see what's going on. This is a double displacement reaction between potassium carbonate, calcium chloride, and it produces potassium chloride and calcium carbonate. You should notice that both of the reactants are ionic and they're aqueous, which means they're dissolved in water. We have two solutions. When they mix together, they give us aqueous potassium chloride, and here's our new product, the solid calcium carbonate precipitate. If you're not sure where this comes from, take a look on your solubility chart and you'll find that when you pair calcium and carbonate ions together, they're insoluble. So how would we write out what we call a total ionic equation for this reaction? So what we do, anything that's aqueous, we're going to break apart into its respective ions. And again, if you don't know the charges, you don't need to memorize them. Look on your periodic table, look on your list of ions because all of that's there. So, first one, we've got potassium carbonate is aqueous. I've got two potassiums and one carbonate, but I'm going to write them in with their ionic charge. So, I have two potassiums because there's a subscript of 2. Potassium has a charge of +1, so I'm going to put that in, and its state is aqueous. Next comes the carbonate ion, which is CO3. It has our -2 charge, and again, we keep the state of aqueous. Next, calcium chloride is also aqueous, so we've got the calcium ion. It's a +2 charge. And then we're going to add in the chloride ion, but there's a 2 there, so make sure we write there are 2 chloride ions. Then we get to our products. So we've got a 2 in front here that's used for balancing, 2 potassium ions and 2 chloride ions because this is aqueous. And then we come to our product. Our product here is a solid. Solid's going to stay solid. It's not going to break apart into its ionic form. So we just need to rewrite it, calcium carbonate, and make sure we put that solid in there. So when you're looking for a total ionic equation, or if you're ever asked to write one, this is what it would look like. Anything that's aqueous that you see in your balanced equation, break apart into its ions. If you have a solid, a liquid, or a gas, it stays as is. You don't change its chemical makeup. You rewrite the formula and keep the state the way that it is. In this example, we have a solid, so over here we've got our solid. Now, if we take a closer look at this equation, you'll notice that there are some ions that appear on both sides of the equation. So take a look and see, are there any ions that are common to both sides of the equation? What you should see that there are two. Over here we've got potassium, and over here we've got potassium. And you'll notice they're in the same amounts. That should happen if they're on both sides of the equation for a total ionic equation. So make sure that you notice the amounts are the same as well. Anything else common on both sides when we take a look? You should be able to see there's chloride ions and there's chloride ions. So which ions are on both sides of the equation are the ones that are in yellow there. Those are our potassium ions, and those are our chloride ions. These ions, the ones that appear on both sides of the equation, we give them a special name. They're called spectator ions. Spectator ions are ones that don't actually directly participate in a chemical reaction. So if you're familiar with the word spectator, spectator means you're watching something happen. So think about sports. If you're not playing the game, you're sitting on the sidelines in the stands, like if you went to a Raptors game and you're sitting in the stands, you're a spectator in that sport. The game that's happening is with the players. You're just watching the action happen from the sidelines. Same idea happens with these chemical equations. When we think about chemical equations, we're making something new. What's our new substance here? It's our solid, liquid, or gas. So in this case, it's calcium carbonate. Potassium and chloride have nothing to do with making calcium carbonate. So we call those ions spectator ions. They're sitting in the solution, they're floating around, they're present, but they're not actually making the new product. Let's take a look at another type of equation, net ionic equation. So what's a net ionic equation? To get the net ionic equation, it only involves the ions and compounds that are used to make our new product. So what's our new product? This is our new product over here, calcium carbonate. What goes into making calcium carbonate? We've got carbonate ion and the calcium ion. So when we write out the net ionic equation, essentially what we do is we're going to keep everything that goes into keeping the new product going, and the spectator ions essentially get canceled out. There's two on one side, there's two on the other for potassium. Two on one side for chloride and two on the other. So anything that's left over goes into your net ionic equation. So for this example, it would be the carbonate ion, the calcium ion, and here's your new product, calcium carbonate. So that's all there is to total and net ionic equations. So I'm going to get you to try one out to make sure you know what to do. So here's our example. We'll move this all the way up. See if you can write the total and net ionic equation for the reaction shown below. So this would be a good time to pause the video to give yourself a few minutes to see if you can write out the total and net ionic equations. And if you want as well, you can identify the spectator ions because those will be the ones that will be crossing out. So give that a try when you're ready, unpause, and we'll go through the answer together. All right, let's take a look at this one. So anything that's aqueous, we need to break apart for our total ionic equation. So barium chloride's aqueous, we've got barium ions, and we've got chloride ions, and we know there's two of them because there's a 2 there. So don't forget how many of each you have by looking at those subscripts. Next, sodium sulfate, 2 sodiums, so I need 2 in front. and 1 sulfate. Then we look at our products. Here's our new product. It's a solid, a precipitate. So this one we do not break apart because we know it stays together as a solid. And our other product is sodium chloride, but sodium chloride again is aqueous and it's going to exist as ions. There's 2 sodiums and 2 chloride ions. So there's your total ionic equation. Now, if we wanted to figure out what our spectator ions are, we're going to look again for the ones that are common on both sides. So what's common on both sides? Chloride ion here, 2 of them, and 2 chloride ions over here. We've also got sodium ions, 2 on both sides. So these ones here are our spectator ions. Next, we can work on our net ionic equation. So again, remember, net ionic equation just shows what goes into making our new product. Our new product is barium sulfate. So what we should only need for that are the barium ions and the sulfate ions. And that's what our total ionic equation shows us. We can cancel out those spectator ions from both sides, and we're only left with the ions that go into making our solid. So we've got barium, sulfate, and then we get barium sulfate solid. So make sure you practice writing out equations, balancing equations, using your solubility table. You'll see some single displacement as well with some of the practice problems thrown in, so you might need to go back to activity series. And then you'll see in the next lesson how we're going to use some of these ionic equations to help us solve some stoichiometry problems.